Okay, we can also find a basis for the null space of a matrix. Let's recall what the null space is. Recall null A is equal to, well, solution set of the homogeneous system AX equals 0. More formally, it's the x's in R. Well, in this case, it's going to be R3 because there are 3 columns here, such that AX is a 0 vector. Okay. Now, once again, we have a nice theorem, which is proven in the book. Not a terribly difficult proof. You can have a look if you like. I'd be more than glad to help you with that if you're getting stuck. The theorem says that if I just solve this AX equals 0 in the normal way, then my basis will come out. So if I just solve this the way I did at the beginning of the course, then my basis will just come out naturally. In precise language, the set of basic solutions, we call them, obtained by a row reducing this augmented matrix. To reduced echelon form. Okay, so the set of basic solutions we get forms a basis. Of null. Hey, so a lot of fancy language in there, but what we need to do is just solve this the way we did in chapter 1, and then our solution will be falling into our laps quite naturally with no further fuss. All right, so let's copy paste this matrix. So I'm going to reduce this. I'm looking at AX equals 0, so I need to, I guess I don't need to, but I should put a column of zeros there. So I'll reduce this to reduced echelon form. That is essential. It has to be reduced, or you will not get a basis necessarily. So if I do the obvious reductions, then most of this matrix disappears. So what do I find? I find that x minus 4y plus 2z is 0, giving x is 4y minus 2z. I should pause and notice that this is reduced echelon form here. That is essential. Make sure it's reduced echelon form. Underline, triple underline, quadruple underline. Where was I? Okay, solving. I throw this into a vector. The vector being x, y, z. And then I get 4y minus 2z, y, and z. Almost there. Almost there. I pull this thing apart. Okay. Hey, voila. These are my basic solutions. These two. Without the y and without the z. So basic solutions. to the vector equation ax equals 0. Therefore, a basis is this set, brace, the set that contains these two vectors. Okay. Now, so I just did a 3 by 3, so of course I will ask you to do a 4 by 6 because I am that kind of guy. So I want you to pause, copy, try, pause, copy, try. I will switch from awful purple to something more palatable, dark green. So pause, copy, try this. And here's the answer. Here's the answer. I got, when I did this, I got 3 vectors. And drum roll, please. What were the vectors? -3, 1, and then quadruple 0, 0, 0, 0, and then -4, 0, -2, 1, 0, 0, -2, 0, 0, 0, 1, 0. So that's the basis I got. So hopefully you were successful there. If not, come and talk to me. I'm a nice guy.